Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem related to buoyancy and center of buoyancy. Okay. In the previous lectures, we have discussed the theory part of this buoyancy and center of buoyancy. So let this lecture discuss some problem related to this. So I have taken a question: find the volume of a water displaced and position of the center of buoyancy for a wooden block of width 2.5 meter and depth 1.5 meter when it floats horizontally in water. The density of this wooden block is 650 kg per meter cube and its length is 6 meter. So yeah, so there is a wooden block is there. Suppose the wooden block is like this. Let's consider like this. So this is the wooden block, and this is going to float in the water. Okay, so after floating, how it will be, like it should be floated in horizontally, not in vertically. It should be floated in horizontally. So I'll draw this. Suppose this is the mark is given. So the front view of this, this rectangle. Let me draw it here. So few part of this block will be inside the water and few part will be outside the water as per this question given. Yeah, this is the block is there, and let mark its dimension. Volume of the water need to find out, and position of the center of buoyancy need to find out. Okay, so volume of water and center of buoyancy. Wooden block width is 2.5 meter. So let's consider this is the width of this, that is 2.5 meter, and depth of is 1.5 meter. So depth is given, that means the height is given 1.5 meter. Okay, so you can draw like this. And next is, so this is the, suppose width is there and this is the height is there, and the length of it is 6 meter. From here to here, the length is 6 meter. Okay, so this is the diagram. Now the density of this wooden block is 650 kg per meter cube. So let write down the data given. We can write the width equal to 2.5 meter, and next is the depth, or you can say the height, that is 1.5 meter, and length equal to 6 meter, and density of the wooden block, that is given 650 kg per meter cube. Okay, so these are the data given actually. Now for this object, suppose this is the point at which the weight of the body acting, and that is nothing but this G point, and this is the point, suppose B point, where the force of buoyancy is acting on this. So let's draw this. Now what you need to find out, that after keeping this object inside to this fluid, what is the volume of water supposed to be displaced. Okay, and what is the center of buoyancy point, that B point, or the height is there, or the height of this B point. So for that, first we need to identify the height of H. Okay, so let identify. First we find out the volume of this block. So volume of block equal to, I can write dimension, what is given, 2.5 into 1.5 into 6. So 6 into 2.5, 50 into 1.5, that is 22.5 meter cube. This is the volume of the block. Now we know that, see, already I have discussed in the theory class regarding the volume and weight of the object. Okay, the force of buoyancy will be equal to the weight of the object, or weight of the fluid displaced. So let's find out the weight. W equal to, we can write m into G, and on behalf of m I can write rho into V, because we know that density equal to mass by volume. So in place of mass, I can write rho into V into G. So rho of the object, already we know that here 650 into volume of the object is 22.5 into 9.81. So this one we can calculate with the help of this calculator. So how much is there? 650 into 22.5 into 9.81, 143,471. So that is equal to 143,471. Some 2 or something is there. That is, this is the Newton. So we know that the body is in equilibrium means, so we need to consider the weight must be equal to the, okay, as I told you previously, the weight of the object is equal to the force of buoyancy. So what the weight we got here, that should be equal to the force of buoyancy, is nothing but 143,471 Newton. That is equal to force of buoyancy. But the force of buoyancy also, you can say that the weight of liquid which is displaced. So also you can write force of buoyancy equal to the weight of liquid, the weight of liquid displaced. So this one we can write again, same thing, m into g, and here m into g place what we can write, again I can write this one m place in the place of m, rho into v into g. So here the volume is nothing but the volume of the liquid, okay, which is or volume of water which is displaced. Okay, so here we can find out FB equal to nothing but FB value already we got here. So what I'll write directly, directly I'll put the value of 143,471, I hope, 471, so equal to rho is 1000 into 9.81 into V. So V is unknown, so I can keep V one side, and let me take it to no side. Now here you can write the volume equal to, we can write the value how much, 143,471. 143,471 divided by 1000 into 9 point, that is nothing but 9801. So near about how much we'll get, some 10, 14, 15 like that. Okay, divided by 9810, 14.62 meter cube. So this much amount of volume was displaced. As the question asked, we got this one. Now the second point, we need to find out the center of buoyancy. The center of buoyancy or position of buoyancy, we know that the value of h need to be identified. For that, what I can write, I can also write the volume of wooden block, volume of wooden block or volume of the object equal to the volume of water displaced. This concept already we have discussed in our theory class. If you want to see that, we can go to the previous lecture. Volume of water displaced, both are same. So volume of wooden block, we can we have already know this one. What is the formula? So what is the wooden block length is there, or width, length, and what is the h, and what is the h in the sense that what is the height is present inside this liquid, that is the volume of wooden block of this. So that is h here will be identified, and the volume of water displaced is nothing but what we got just now, 14.6. So we'll keep h one side, and here what I'll keep 14.6 divided by 6 into 2.5, that is nothing but 15. So here we'll get 0.9 something, will get it exactly, divided by 15, I can do directly 0.975. 0.975 meter. Okay, so this is the h value. That means the total height of this object which is inside the water. But we need to find out the center of buoyancy point, the B point. So that is nothing but we can write the center of buoyancy equal to, just to divide this h by 2. that is nothing but 0.975 divided by 2. So we'll get 0.44875 meter. Okay, so this is the center of buoyancy point for this object which is inside the water level. So let's see one more problem related to this. Find the density of a metallic body which floats at the interface of the mercury of specific gravity given here, and metallic body given. Okay, which floats at the interface of a mercury. Okay, mercury interface and water, such that both mercury interface and both water is there, such that 40% of its volume is submerged in mercury and 60% is in water. It's some different kind of things given, it is not a single liquid. So here we need to consider, let's consider here, this is the liquid which is present here inside. This is the liquid is there, and this is suppose a different liquid, another one liquid. I'll draw it here, another liquid, because two different liquids are there. So one liquid, let's consider water, another liquid is mercury. So let me give this one as a mercury here. This is mercury, and this previous one, this one is water. Okay, and the object we can draw it here. So the object is there, metallic body is there. This is the object which is present here. Now 40% of its volume submerged in liquid, submerged in the mercury. So 40% of that body is inside this mercury and 60% of this body is in the water. So we need to find out the density of this metallic body. Okay, so we need to calculate the density of this. So for this, any other data are given, let's check it. No, only specific gravity given. Specific gravity of mercury 13.6. So we can find out the density of mercury is nothing but multiply into 1000, we'll get 13,600 kg per meter cube. And density of water, we know that 1000 kg per meter cube. Okay, so let first, no data are given, so let first consider the V equal to the volume of the body, okay, and 40% of volume is submerged in the mercury. So we can say the 40% of the body, that means 0.4 V is inside the mercury level. Inside the mercury level is there, correct. Now similarly we can write 0.6 V is inside the water level is there. Okay, now for equilibrium condition we need to satisfy the what? For equilibrium condition we can write, for equilibrium condition we can write the total buoyant force, equal to the weight of the body. The total buoyant force equal to weight of the body. This one already we have studied in the theory class. Okay, in the theory lecture we have discussed this one. So now this one we can write the total buoyant force. Also we can write, okay, the force of buoyancy due to water. The force of buoyancy due to, because two liquids are there, that's why due to water, and the force of buoyancy, direct I'll write here shortcut, a B, due to the mercury. Okay, these 2 points we can consider, because see, I've not written any different thing, only same thing I just modified here. The force of buoyancy force equal to the force of buoyancy due to the water and force of buoyancy due to the mercury. So now we can find out first thing, the force of buoyancy due to water. The force of buoyancy due to water. Due to water we can write the weight of water, displaced. This formula we know already, the weight of water displaced by this body. So we can write here weight of the water equal to nothing but we can write mg. Again, in the place of mg, m, I can write rho v g. Okay, so here you can see rho of this water is nothing but 1000 g 9.81, and into the volume what is given 0.6 v, because 60% of this content of this object is inside the water only, so volume is 0.6 v. So this one, the force due to the water, this one you give an equation 1. Now similarly the force of buoyancy due to mercury, similar thing, again weight of mercury, you can write weight of water, weight of mercury displaced by the object. Okay, let it right, the weight of mercury displaced by the body. Okay, so that again we can write similarly, that is weight of the body or weight of the mercury displaced. So this one we can write equal to mg, and in the place of m again we can write rho vg. Similarly rho equal to, we know that 13,600 into g 9.81 into v, volume how much, 0.4 v. Okay, this much Newton. This one given equation 2. So these two equation we got from here. Now we can write the weight of the body, how much, the weight of body, simply we can write mg, in the place of mg we can write directly rho vg. Okay, now this one equation 3. Now this compare this equation 1, 2, 3 for equilibrium condition. We can write for equilibrium condition, we can write all this equation. The total buoyancy force equal to weight of body. So this one we can, the total buoyancy force is nothing but the buoyancy force of this and the buoyancy force of this one equal to weight of the body. So we can write buoyancy force with the mercury 9.81 into 0.4 v plus 1000 into 9.81 into 0.4 v equal to rho gv, weight of the body. And now here gg can be cancelled in the all the sides. So because this 9.81 and g, we can cancel both the side by taking common on that. Okay, now what if the remaining parts will be there? So 13,600 into 0.4 v. So let's calculate this. 13,600 into 0.4, that is nothing but 5440 v. Okay, next 1000 into point v, that is nothing but 400 will get. So plus 400 b equal to rho into v. Okay, so now we'll get how much. So this is yeah, this is 4. Okay, sorry, here 0.6 will be there, so that means 600. This is 40%, this is 60%. Okay, now this is 600, so you can get how much, 6000. So if you add both the things, we will get 6040 v equal to rho v. So finally we need to find out the rho value. So density equal to this v cancel we can do, and remaining what will get 6040. This is kg per meter cube. So this is the density of the object, the metallic body which is present. So see here, if you see the question, no data are given except the specific gravity and this 40% of volume of this water and 40% of volume of this water. This 40% is inside the mercury and 60% is in the water. So still we can able to find out the density of the metallic body. So this is the procedure we need to follow to solve the problem related to this buoyancy and center of buoyancy. I hope you understood how to solve the problem related to this. If you are having any kind of doubt on this, you can give a comment on the comment box. Thank you all.